So let's begin our discussion today on ocean currents and the notes that you've written in your journal. Suppose you sent a message in a bottle. Could you predict where it would land? Yes, you can make that prediction. Pay attention to this chapter and you will learn where the ocean currents will take your message. So Chapter 5, Ocean Currents. We began our discussion in class about Thor Heyerdahl and the crew of 5 men plus him who launched off of Peru and allowed the ocean currents to take their raft, which was named the Kon-Tiki, on the travels that it would go throughout the oceans. Thor was theorizing that ocean currents existed in the ocean, and no one at that time had that theory. So this was his experiment to be able to test and see if those ocean currents truly exist in our oceans. The currents did take the Kon-Tiki raft all the way to Polynesia, which was his theory that the Peruvian people were taken there 1,500 years ago to settle in the islands of Polynesia. It took them 97 days to be able to reach land, and from that point on, studies were made regarding the ocean currents that flow in our oceans. So what is an ocean current? It's a stream-like movement of ocean water which follows a regular pattern. This was the raft that traveled that distance of 3,728 miles across the oceans to reach Polynesia. So there are two types of ocean currents. We have surface currents and deep currents. We'll talk about deep currents at another point. Today, I'd like us to talk about surface currents. So surface currents are the horizontal movement of ocean waters. Remember, horizontal is the back and forth motion in the ocean. These occur near the surface. There are 3 factors which control the movements of those surface currents. One of those is global winds. These are winds that blow all around the world in regular patterns. Another one is the coriolis effect, which we will discuss in a few minutes. And the last one is continental deflections. Remember, continental has to do with the continents themselves, and the term deflection means to change direction. So let's discuss the global winds. These are those winds that blow across the Earth's surface. They create our surface winds on the ocean. Near the equator, these winds blow in a pattern that flows from east to west. An easy way to remember that is the E in equator, east to west. Notice I underlined that E. That might be a good thing for you to do. Underline the E and then do E for east to west. Near the poles, the winds near the poles blow in an opposite direction. They blow from west to east. There is a picture below that shows the Gulf Stream current, which flows up the eastern coast of the United States. If you've ever been to any of the beaches on the east coast of the United States, from Florida all the way up to our northern beaches in Delaware, you will realize that you have been swimming in the Gulf Stream current that is in our Atlantic Ocean. And notice as the Gulf Stream current flows up the coast of the United States, this current is warmer and it's allowing the warm water from the equator to flow up and warm the higher latitudes in the northern areas of the ocean. Let's talk about the term continental deflections. Surface currents that hit continents and deflect or change direction. So if you'll notice in South America, the Brazil current flows. It's in the southern hemisphere, so it flows in a counterclockwise direction. In the northern hemisphere, the continental deflections go in circular patterns that go in a clockwise direction. This Brazil current flows, it hits the southern, the coast of South America, and it flows, causing it to flow away from, instead of washing across the continent, it flows down. So does the temperature of the ocean water really matter? Yes, it does. The water from all of the oceans mix together. So water that's near the equator would be what temperature? I hope that you filled in that that water would be warm since it originates at the equator. So if you didn't fill that in your notes, please do that. Water near the poles, conversely, would be what temperature? If you thought cold, you're exactly right. That water originates at the poles, so that water would be cold. These waters circulate to make warm or cold currents in our oceans. Let's go ahead and discuss the Coriolis effect. So the Coriolis effect is the curving of moving objects, whether it's objects that aren't attached to the earth, such as our waters, or possibly a ball that you're rolling across a merry-go-round. Anything that is moving from a straight path to a curved path. The reason for that is because of the Earth's rotation. In the northern and the southern hemisphere, surface currents move in different directions, depending on which hemisphere they're traveling in. In the northern hemisphere, these currents turn clockwise or to the right. In the southern hemisphere, these currents turn counterclockwise or to the left. So the patterns in the northern hemisphere would be clockwise, as you see my cursor moving, or in the southern hemisphere, they would be counterclockwise, as you see my cursor moving. These were clips that are on your journal notes that you could have seen. So if you'll go back to those notes in your Canvas course, you can click on each and it will take you to a clip regarding the Coriolis effect. You drew this table in your journal notes. These are the 3 different temperature scales that scientists use in Fahrenheit, in Celsius, or in Kelvin. Boiling point in Fahrenheit is 212 degrees Fahrenheit. In Celsius, it's 100 degrees Celsius. And in Kelvin, the boiling point is 373 Kelvin. Freezing point in Fahrenheit is 32 degrees Fahrenheit. In Celsius, freezing point is 0 degrees Celsius. And in Kelvin, it's 273 Kelvin. This was a picture of the Coriolis effect as it is moving clockwise in the northern hemisphere, and in the southern hemisphere, it is counterclockwise. Here is the Brazil current that comes down, hits South America, and it causes it, as it rotates around, to be counterclockwise. Here was the map that you had in your journal notes. I asked you just to look at this, not to write. As you see the Gulf Stream current going up the United States, as it gets up higher latitudes, it splits, it goes, hits Europe and Africa, and then as it gets to the equator, it continues in a clockwise pattern of movement. Notice the temperatures. Remember, warm currents are red, cold currents are blue, and you can see as the Gulf Stream is traveling up the United States and as it splits and hits Europe, we even noticed in one of our videos that there are palm trees which grow in Ireland. And palm trees, you know, typically grow in warmer climates. In Ireland, it's a higher latitude, so we would expect it to be colder. Nope, the warm waters that flow against the coast of Ireland cause that warmer climate there on the coast. Therefore, they have palm trees, which grow in Ireland. That's all I'd like us to talk about today. Thank you for listening and following along in your notes. Have a great day. The choice is yours.